We know the data science is hard enough when working with metrics, customer chunks, ad clicks, and cart abundance. And even when the stuff collected internally is patchy, with data quality is leaving a lot to be desired. But they are numbers. They behave to a certain extent. You know what doesn't? People, particularly when the pessimist emotion of love are involved. I tried to build a linear regression model to predict romance, thinking there would be a fun Valentine's experience and an interesting feature engineer challenge. Instead, I found the inconsistency, bias, and an impossible variance. And today, we're gonna learn just how important domain knowledge is to data science. Welcome to my data science nightmare. As a data scientist, I'm pretty sure I have the skills to tackle this project, but I have one big challenge standing in my way. I don't work for Hinge or Match.com or insert your favorite modern dating app platform here. And that means I don't have access to big swaths of data of real singletons looking for love. But to train a supervision model, I need labels. I need a data set where the success or failure of relationship is a known fact. So instead of mining the love lives of people that I know, I'm using something we all obsess over anyway. TV characters and their relationship and the messy love stories that we all know by heart. Now that I have got that idea, I need an actual plan. First, I had to build a data set where every character has their basics. The height, the hair and eye color, the actor who played them, and the TV show they are from, and also their personality type. Then we needed the relationship side, who they dated and what the relationship status was. And honestly, wouldn't that be amazing if a data set like that already exists on Kaggle? Yeah, we can dream. But in reality, this kind of data doesn't come neatly packaged. It's messy, incomplete, and spread across different sources. So I had to break the problem into smaller chunks and build piece by piece. To keep this manageable, me and my team picked around 50 TV shows that we know and love. Plus, I feel they are just too iconic to ignore. Like, we had to include Game of Thrones. The relationship dynamics are literally unhinged. If I miss your favorite TV show, tell us in Discord and I'll add it to the list. We also limited to about 50 TV shows that we actually know on purpose. That wasn't just to make scraping easier. It was because domain knowledge is basically a cheat code to data science. When you understand the world behind the data, you can spot what is the real outliner versus what is just an arrow. For example, if I pull the character's heights from Game of Thrones, the minimum height in the dataset is going to look wildly low. But if you didn't know the show, you might think that has to be a bug. But if you do know the show, you immediately realize that's not a data issue. It's because one of the characters is played by Peter Dinklage. And this outlier is real, and it's actually what makes the dataset more accurate. So choosing the shows we know wasn't a bias, it was a quality control. First, I pulled the basics from the movie database. The show, the characters, the actors, and gender. Nice, clean structure, the kind of data that gives you the false confidence. Then I needed the personality types. I went to a fan-voted personality database, where fans basically treat the fictional characters like real case studies, vote on their Myers-Briggs type. And by the way, if you did not know, Myers-Briggs, the MBTI, is the personality framework that groups people into 16 types using 4-letter pairs. The E and I, the extroverted versus introverted, the S and N, the facts versus patterns, the T and F, the logic versus values, and the J and P, the structures versus flexibility. And honestly, if anyone has the ultimate domain knowledge here, is the fan base. Those people know the characters better than the writers. And the funniest part is that the most common personality type in the whole data set, it was the ESFP, the extroverted centered feeling perspective, also called the entertainer. We can all agree that Joe from Friends is basically the mascot from that type. For the hair color and the eye color, I had to go hunting through images because there's no proper database that just hands you the character's eye color in a clean column. And this is exactly where domain knowledge matters. Actors don't always look like their characters. They dye their hair, wear contacts, and sit in makeup for hours. And sometimes they end up as actual aliens, like in Star Trek. So if I pull the actor's real features from a random bio page, which doesn't exist by the way, I try, I'll be training my model in the wrong face. So I had to do some funky machine learning to get this right. And if you want a follow-up video on exactly how I did it, tell me in the comments. Also, a quick limitation. This works way better for hair than eyes. Hair is usually big, obvious, and consistent across the scenes, but eyes are tiny in most screenshots. Half of the time, the face is in low res, so the iris is basically a handful of pixels. And then we got lighting, color grading, and filters on top. So eye color quickly turns out into enhance, no. And finally, for the height, because no one just had the character's height column lying around, I used the celeb's height to estimate the character's height based on the actor. That part got messy fast because I made a mistake by matching the characters instead of the actress name. And some actor names didn't line up and few merges failed, so I had to rerun parts of the pipeline to fix my errors. By the way, how I wish I had the EvilWorks pub platform for these, because it significantly cuts down the rerun time by only rerunning the parts that change. But that tool has only become available in the last couple days. And we are going to have a closed beta so you can use it in the next month. So hit the link below to find out all the details. Now, the most difficult part, and honestly the most crucial part of this whole project, was getting the relationships of each TV show. I wish there was a clean magical data set just listing every single couple, who dated who married who, but no. Of course not. At first, I tried doing the hard way. Digging through fanwiks and forum pages show by show. That was easily the most painful part of the entire pipeline. And then I had what felt like a genius idea. I asked ChatGPT to list every relationship in each show. At first glance, it looked pretty accurate. But when I actually checked properly, I noticed the problem. It didn't just miss the relationship, but invented some, like fully fabricated couples that never happened, which is exactly the kind of thing that would quietly poison your analysis if you don't have the domain knowledge. So I went back, manually reviewed each show's couples with the help of my colleagues who actually knows the shows, and that's what made it possible. And it worked, but it was tedious. And at the end, we labeled every couple with the relationship status: married and dating, broken up or divorced, secret or kissed. From there, it was just a matter of stitching everything together so each couple had a full profile. Both personalities, both heights, the hair color, the eye color should be all in one place. And then I could start feature engineering, basically turning the raw attributes into signals that the model can actually use. So instead of feeding the model two separate personalities, I created are they identical and how different are they, like introverted versus extroverted, S versus N, and so on. And for physical attributes, I added the height difference in centimeters because a raw height doesn't say much, but the difference in mine. And for appearance, I created the same eye color and the same hair color as binary flags, because this is an easier way to test it where the superficial similarity shows up in patterns. It's not about believing if those features explain love. It's about seeing what the data thinks and actually explain. And I also found a data set that matches the pairing into a simple relationship category: best, average, worst, or one-sided. So for each couple, I check the compatibility in both directions, A with B and B with A, and then I combine that into one label. If both sides are the best, it's the best. If either side is worse, it's worse. And if only one looks good from one side, it becomes one-sided. And that gave me one clear feature, the MBTI match type mutual, that turns two types into something the model can actually learn from it. And here's what I did next. I turned all those messy relationships labels into a simple numerical target so I can keep the modeling step simple. First, I mapped each relationship status to a score. Married get the highest score, dating is strong, broken up is low, and secrets is negative, because that usually isn't a healthy sign. And then I did the same for the personality compatibility. Best match get the most points, The worst match get negative points and one-sided sits right in the middle. After that, I just add them together. The relationship scores total is equal to relationship scores plus MBTI score, and that combined score became my target. So target equal relationship scores total. Now, the real important part. When I trained the model, I tried to be real strict with the leakage from the start. I removed the targets, removed the columns that I used to build it, and I dropped the identify fields like show name and character name so the model couldn't just memorize the couples. At the time, I generally thought that I removed all the ways that the model could cheat. I will come to realization after. But in the meantime, I kept the model simple. A basic linear regression is a sanity check. If the model gets too good to be true, the results means that there's still some leakage. And if it struggles, it tells that the problem is generally hard and the data might be noisy. So I built a clean pipeline, split into train and test, input the missing numbers with the medium, inputting the missing category with the most common value, one hot encoded categorical columns, train the linear regression, and evaluate the mean absolute error, the RMSE, and the root square. And honestly, the results looking shockingly good. The mean absolute error was 0.34, the root mean square error was 0.49, and the root square was 0.92. And on paper, that's incredible. I felt like I cracked love, which is exactly why I got suspicious. And this is where the too good to be true moment hit. At first, I dropped the obvious leakage columns, like Myers-Briggs scores that I created and the compatibility label that I used to generate it. But still, I had one massive cheat code sitting inside the features, the relationship status. Because think about this, the relationship status is basically the outcome. If the model can see married or broken up, it doesn't need to learn anything else about the couple. Is already starting at the answer. So I reran the whole thing properly and removed the relationship status plus all the identify field like show name, character name, actor's name, same target, same pipeline, but just removing the shortcuts. And the performance fell off a cliff. The mean absolute error was 1.19, the root mean square error was 1.45, and the R square was 0.36, which is way more realistic. And honestly, this is the real story of the project. The first model wasn't predicting love. It was predicting the information that I accidentally let it see in. And once I removed the leaks and the model was forced to rely on the actual features like Myers-Briggs distance, the height difference, head and eye flags, and suddenly the problem became hard again. And that's a real win. Domain knowledge beats the fancy models. And the hard part wasn't training linear regression. It was knowing what to not include and in what would that model cheat and what the features that could exist before the outcome. The fan base gave me the Myers-Briggs labels, but the real work was turning that into usable signals. The mindset doesn't stop with romance dataset. It's the same skill that we needed in business problems too. Take customer churn. One side of the relationship is the company, but the other side is the human, which is messy, emotional, and ultimately the one that decides to leave. And if we understand how people break up, we can stop treating chart like a random arrow and start treating like a predicting pattern. And that's something that I will swipe right on. If you like videos like these, like and subscribe. See you on the next one.